So you got the basic parts of unit tests, writing unit tests with JUnit framework. Now I'd like to show you some more details about unit testing. So first of all, I like to show you how to write a test case for a non-static method, and in this case for a very special method. We like to write a test for this service class here. So we don't have any Spring yet, but we have a service class that has a folder where it stores some files. This folder is actually getting introduced into this class by the constructor and isn't changed beyond that. So if the first time the constructor is called or the constructor is called, this folder is fixed. We can't change it afterwards. And we have a method that saves these first argument here, the text, to a file name named like file name that is actually created in this folder here. So that's it. It's a simple service class. So what we like to do now is write some tests. So how do we do that? We use the same shortcuts as before, Control-Shift-T, create a new test case. Just say we want to create a test case for this class, and there we go. So what we actually need to do now is to write some setup, right? We need a file service. So what we do is, I showed you in the source view, just by example used before, and say something like public void setup. Setup is a good name for this method here. And we say we want to create a file service. And this should be a new file service. And I don't know. How can I do that? We can actually create this variable here, field actually. Say it's a file service field, and we can reuse this later in our method here. Now we can say something like file service dot save to file, and let's say we want to save the text hello to a file named hello.txt. So maybe you see what the problem is. We have to handle this folder here. We want to specify a folder where we can just put data for our test cases. In order to do that, we could create a file or folder here at some level, system dependent level on the temp folder or something like that. Or we could use this very easy approach. It's called to apply a rule. So there's a rule for this case, especially for creating files, just for test cases. So we can use the notation add rule and say this rule is a field of the class, of the test class here, and has to be public. We are not allowed to declare non-public. We have to create a public. And the rule that we need is temporary folder. So temp folder, in this case here, and we just create a new temporary folder. And this does handle all things for you. Actually creates a temporary folder for all the test cases inside of this class, this test class. And what it also does, it just cleans up after the test execution. So you don't have to handle something like was the file created or not? Do I have to delete the folder or not? This is all covered by this simple rule here. And now we can just provide our constructor with this file name, this path to the temporary folder. And now we can use this one here for also for our assertions. So we saved this method, this text to the file, and now we want to check. How can we check that? And you can say something like temp folder get root. Now we want to create it convert it to a path. A path is of the new Java I/O API. In a special class, it's just represent a path in your file system, and we can say something like resolve, because we want, as you saw in the method of the file service, we create the file name just beyond this folder that we introduced through the constructor here, and it should be the same as these here, right? So we just extract a local variable here, say something like file name, and we want to resolve this file name here. Okay, so now we have a path, and we actually want to extract that path because we have to reuse it in two different asserts that are just coming up, to say something like created file, and we want to assert something simple like true. Could be a good thing that the file actually exists. So if we call the method file service, create a file service say file, it should be the file that we wanted to be created should be created after we call that method. It's pretty clear. The file dot exists. So that's the first thing you want to check. And the second thing we might want to check is if actually the tests or the input hello in this case is in the file. So not that we only created the file, but also that the file has a correct content. So what we do now is we read all the files. We can use that using the new Java I/O things too. We can say read all lines, provide the path of the created file, and this method actually returns something like a list, and a list of each line, a list of strings where each element of the list is one line and ordered by the number of the line. So we just have one line because we have just printed hello in this text file, so there should be just one line, and we can say something like contains. Contains is also a harmcrest matcher. And we can see here contains, there's something like contains any order, but we don't need that. We don't need contains string. Where's my contains method? Ah, here is it. We can use alt enter and import it statically and say something. What should it contain? It should just contain hello. So now we can just execute all the tests and wait for the result, and hopefully it just works. The cool thing is, as I said before, you don't have to care about cleaning up after your test, because that's what the rule that we applied actually did for you. There are more rules. There are a lot of different rules. For example, for exceptional state, I will show that to you later. But for other purposes, you just go to the JUnit GitHub site and look up for the rules, and there are lots and lots of them. You can write your own if you like. You can write class rules, which are pretty much the same as rules, but like the before class thing is just, they are just getting executed once for a whole test class, not for each test case in this class. So the test actually runs. We can now, sorry for that, we can now look at the test results here again. We see, it's from the first example. So we have file set service test and everything is okay. Nothing is actually, there's nothing to complain about, so everything is okay. We wrote a good test here. We covered hopefully all branches. We can check that too. So we can go back here, look at our package, look at file service. Oh, I just executed test, right? Yes, so we don't have the new actual report here, but it should cover almost all cases in there. So that's for the rules. Maybe now you have, just as I showed you, you have at some point you may have lots and lots of different tests, and you somehow want to bundle these tests, or just run one test. To just run one test, you can just type in something like tests and put a filter in here and say I want just to run file service test. If you do that, then just the one file service test gets executed. If you have lots and lots of tests, at some point it could be interesting to just execute. Sorry, I missed one minus here. You can just provide these argument and filter the test cases you want actually getting executed because of too much overhead. You don't want to wait until all tests are finished. You just want to look if this one test that you actually wrote is running. So that's just one test getting executed, and it should be only the test of the file service. So if you look at our whole results, there's only the file service test class here. You can do that with all the different test classes. But as I said, maybe you want to bundle your test. You can use it. You can do that by just for some reason you want to create a test suite. So you can create a new class here, say my test suite, and now we can say something and provide the run with applies a special runner for your JUnit test. In this case, you want it's always a class, so we want it to be a suite. Suite is from JUnit. To implement that, import that, and now we can bundle different tests in our suite and say something like we want it to contain. What did I do? Oh, that's right. It's just confusing here. So we want it to contain the file service test class only, for example. We can do that. And now we can do the same thing as before. We can say test, and we can say, not this one here, we want to execute only the test suite. And it should be the same result. And we can provide multiple classes in this array here, in this argument. And just to combine different sets of your classes, and maybe you want to do something like slow and fast tests. You can do that with suite classes, but you can also do this with categories. Categories is also interesting, but I don't show that to you for now. You can look it up. Just to give you a hint, you can somehow provide some macro classes and categorize your tests and say something like just run. In your test suite, you can say something like, this is all the classes, but now just run the slow test, or run the fast test, or I don't know, run the Linux test and run the Windows test, and something like that. Okay. That's about suite classes. What else is there? At some point, you may want to ignore tests. You want to skip them. You can simply do that by using the add-ignore annotation. At method level, or if you want to skip a whole test class and all test cases of the test class, you can put it up front. If you do that, you can just run test in this case to get something interesting. So now all tests are getting executed again. You will see that there are actually 4 test cases, but 3 are skipped. So wait for the results to actually be here. Why are not my test cases here? Ah, there. Yeah, now it says we have 5 test cases, and 3 are actually getting ignored. So look here again. See, all I ignored. So be aware of these annotations. At some point you may need it because you can't fix the test, but you shouldn't use it very often. Okay, that's ignore. Now there is a last thing I want to show, almost last thing I want to show you is exceptions. So maybe you want to test exceptional state. It could be the case that your file service throws an exception when you provide for example, I don't know, a wrong file name because the file system couldn't handle I don't know, special characters in the file name. Then you might get an exception, and to provide or to check against an exception you can write another test case. Let's say we have a second test case for our save file method. We can call them save to file, exceptional state, for example. It doesn't return anything here. It should actually throw an exception. It doesn't have to, but would be a good idea in this case. And we can provide here something like expected and say, I don't know, file name, file not found. We can do something like file not found exception. This is cool. So what happens now if we just keep this method empty and we run the tests? The test should fail because there's no exception actually getting thrown. So the test expects the code that is inside the method to throw an exception. That is what we actually wrote here. You see? Look at the test cases again. Go back. We're getting them. We're getting two of these here because we have the the interesting thing is we have the test suite here and the test suite containing this file test service again. So we execute the test 2 times. That's why we're getting 2 failures here. But that's okay for now. You see here the file not found exception is expected and we don't get one. So as I said, test simply fails. So if we now throw an exception here, the test would actually work. This is one possible solution. Another possible solution would be to use a rule. There's also a rule for that. We can use a rule that's called public exception rule. What's the name, I think? Exception rule? No, not exception rule. It was expected exception. And you can say something like exception, and this is exception expected exception none. So for default we don't expect any exceptions to happen because this rule applies to all different files here, different test cases here. We don't want to throw an exception in this case because it doesn't throw an exception, but we wanted to throw the exception here. So before we do that, I will just throw an exception here to show you that it actually... no, I don't show you that. I want to show you that this method actually fails too in this case. So I remove that, and now I want to say something like, when I call this method, there should be an exception, and this exception should be of type, as I said before, or as it was before mentioned, file not found exception dot class. So, and that's it. Now the test should fail again because we don't throw an exception. In order to fix that, we have to write the test case for that it always throws an exception. But we don't do that here. I just wanted to show you what you can do to check against exceptional state in your tests. Wait for it, and now it fails again. Hopefully with the same, almost the same message. Expected test to throw an instance of Java IO file not found exception. A little bit different, but the purpose is quite the same. The cool thing is you can actually do more things here. You can just if you use the annotation, you can just say it throws an exception of this special type. But what you can do with exception expect is you can define multiple things like, I don't know, the cause. You can assign the message of the exception with using a harm cross matcher if you like, and do all the different things. It's pretty cool and much more powerful than using the annotation style. The annotation style is just for simple assigning something like array index, out of bounds exception, or exceptions that you don't care about, didn't write on your own, and just trying to cover in your test cases and don't have any influence of on the messages there. But for all the other cases, I would prefer using the rule exception, expected exception. Okay, that's that. Another interesting thing and last thing I want to mention before you get bored all the way is something like assume. There is also a possibility that you can use assume in your test cases, and assume is for saying skipping the test in special cases. So conditionally skip a test. You can, for example, think of file separators. So let's say we have Linux and Windows systems, and we just have this test. I know in this case we don't actually have a case here, but we want to assure that we want to assure that the file separator is always the one from Windows. So we say, or from Linux, I don't know. We want the file separator to be equal to, let's say, slash, or say backslash, because I have a Linux machine here. So if we do that now, the save to file test case gets skipped. You will see that just in a second when the tests are getting executed. And the results are here, hopefully. I'll just go here and show you the results. Wait. As you see, we got 7 tests. And we get, because we have a test queue, they're doubled here again, but the save to file test is actually skipped. And that's what is done, or was actually done by these introduction of the assume command here. So assume just checks this condition. If this condition is true, of this command, it says, oh, it's a true thing, so we can go on with our test. If it doesn't fit, the test doesn't fail, is ignored and skipped. So you can, maybe you have some test cases just for a special operating system. You can do that by using the assume methods. So I think I got all the main parts of writing unit tests. So you have a good set to start with. Look up the documentation on GitHub for the JUnit project. And for more advanced topics, we will talk and discuss about it in the labs, and further topics like BDD or using Spock framework for writing really good looking tests. I will refer to further lectures and videos that are upcoming in the next weeks. So thank you for your time, and I hope you're good to go and write cool unit tests.